Hello guys, let's learn about field effect transistor. What is a field effect transistor? Field effect transistor is referred to as a FET. This semiconductor device serves as a number of functions in electrical circuits, such as an amplifier or voltage control switch. The three terminals of a FET are the drain, gate, and source. Introduction. The three terminals of FET are known as gate, drain, and source. Gate is denoted with G, drain is D, and source is denoted with S. It is a voltage control device where the input voltage controlled by the output current. In FET, current used to flow between drain and source terminal, and this current can be controlled by applying the voltage between the gate and the source terminal. So this applied voltage generates the electric field within the device, and by controlling this electric field, we can control the flow of current through the device. Here we have already gone through the BJT, bipolar junction transistor, and this is the field effect transistor. You can see what is the main difference. This is the symbol of BJT and this is the symbol of FET. And here you can see we have three terminals: base, collector, emitter, and here we have source, gate, and drain. The basic difference of the terminal name and the symbol. Next, the bipolar junction transistor has two main disadvantages. Why we need FET? Because bipolar junction transistor has two main disadvantages. It has low input impedance and it has considerable noise level. To overcome this problem, field effect transistor was introduced because of its high impedance, high input impedance, and low noise level than ordinary transistor. Junction field effect transistor is a type of FET, and basically FET are available in small size and they use low space on a chip. Types of FET. There are two types of FET. First one is junction field effect transistor, which has N-channel JFET and P-channel JFET. And second one is IG FET, that means insulated gate field effect transistor stand for. And MOSFET stand for metal oxide semiconductor field effect transistor is a type of IG FET, where a layer of SiO2 is used as an insulating layer to isolate the gate from the channel. The MOSFET can be further classified into depletion type MOSFET, N-channel and P-channel, and enhancement type MOSFET, that is also N-channel and P-channel type. Junction field effect transistor. In JFET, this gate terminal is provided using this PN junction. So if you see the N-type JFET, two small P-type region are fabricated near the channel. You can see here in the field effect transistor. Here is drain, here is a source, here is a gate, and we have P channel. Two small P-type channel region is here. And this channel is made up of N-type semiconductor, then it is known as N-channel JFET. And likewise, if it is made up of P-type semiconductor, then it is known as P-JFET. Features of JFET. JFET is a voltage control device, that is input voltage control the output current. In JFET, the width of a junction is used to control the effective cross-section area of the channel through which current conducts. It is always operated with gate source PN junction in a reverse bias. Because of reverse bias, it has high input impedance. In JFET, the gate current is 0, that is IG is equal to 0. Theory of operation. When gate source voltage is applied and drain source voltage is 0, when VGS is equal to 0 volt, two depletion layers and channels are formed normally. When VGS increase negatively, then V is greater than VGS of, that is gate and source voltage. Depletion layer are also increased and channel will be decreased. When VGS is equal to VGS of, then depletion layer will touch each other and channel will totally remove, so no current can flow through the channel. Here you can see this is the depletion layer. This is a P-type material, this is an N-type of material. Here is a drain, here is a source, here is a gate. Once VGS is equal to VGS off, see here you can just go through and check in the figure. The first condition is here, as you can see, the applied voltage V0 is equal to VGS is equal to VGS off. Then depletion layer will be in this state. And then depletion layer also increases and channel will be decreased. Channel will be decreased and depletion layer will be increased. In this condition, the depletion layer will touch each other the depletion layer is touching to each other, and channel will totally remove. The channel is totally removed, so current can flow through the channel. Then current can flow through the channel. And now when drain source voltage is applied at constant gate source voltage, this is the condition. Just go through the line by line, you will understand, and see the graph here. You will able to understand. Just make sure that you have to go through with the depletion layer. You have to check what is the depletion layer, where is the channel, where is the source, where is the gate, and where we are applying the voltage. Just make sure to check that and just read once this. You will able to understand the operation of gate source and drain in that condition. And characteristic between I and V, it is the curve between the drain current ID and the drain source voltage VDS. For different gate source voltage, that is VGS, can be characterized as, this is the relation between ID and VDS. When current is increasing, see what is the effect on the voltage. This is the pitch off region, and this is the breakdown region. This is the saturation region. And this curve shows the value of ID for given value of VGS. This is the transfer characteristic between ID and VGS. And IGFET, insulated gate field effect transistor. IGFET used as insulated layer between the gate terminal and the channel, and typically this isolated layer is formed from the oxide layer of the semiconductor. The name IGFET refer to any type of FET which has an insulated gate, and the most common form of IGFET is the MOSFET, that is metal oxide semiconductor field effect transistor. Here is the symbol, schematic symbol, where you can see this is the drain, gate source, and substrate. And here the physical diagram, where you can also check the drain source and substrate and channel, P channel. Metal oxide semiconductor field effect transistor. Here you can see source, gate, drain. This is the oxide layer, this one, and this is the metallic layer, and this is the channel and depletion layer. And P-type substrate is here. In this MOSFET, the gate is made up of a metal layer, and the insulated layer is made up of silicon dioxide. That's why it's called metal, because it's made of, the gate is made of metal, and the oxide because we are using silicon dioxide for the insulating layer. Because of that, it's called metal oxide, and it's a semiconductor device. It's called semiconductor field effect transistor because there is an effect in the field, and it has three legs: source, gate, and drain. Because of that, it's called transistor. Classification of MOSFET. The MOSFET can be further classified into two: depletion layer MOSFET and enhancement type MOSFET. And here you can also see where it could be depletion layer MOSFET N-type channel, and that could be P-type channel, and enhancement also. This is the depletion type MOSFET, and this is an enhancement type of MOSFET. You can see what is the difference. You can just identify, just go through the figure. You'll be able to understand exactly what's going on. Make sure while you are trying to understand any concept, make sure to understand the graph first. Then you will be able to understand what is going on there. When we apply the voltage at the gate terminal, then due to the electric field, it can either deplete or enhance a number of change carriers in this given channel. So by the application of voltage, if the number of charge carrier gets depleted in the channel, then it's known as a depletion type MOSFET. If the number of charge carrier increases, then it is known as the enhancement type MOSFET. Advantage of FET: it is a simple to fabricate, smaller in size, it has longer life and higher efficiency, it has high input impedance, it has negative temperature coefficient of resistance, it has high power gain. Disadvantage of FET: JFET has low voltage gain. Disadvantage is JFET has low voltage gain. They are more costly than junction transistor. It has low switching time compared to BJT. Special handling is required during installation. Applications of JFET: we can use as amplifier, in oscillator, in analog switch, integrated circuit, buffer application. These are the advantages of application of JFET. These are the application where you can use JFET. Thank you.